to send me the answer of this. Okay. And if you have already practiced this question, just let me know, because I am going to do it, give it from NCERT. Okay. And if you have already done it, just let me know. We won't waste our time. Have you done this question before? Yes or no?
No.
Okay, please do it. First, you are going to uh, write the name of the first and send it to me in chat box. Ravi, am I audible? So the name of this will be basically 1, 2, 3, 4, 5. So the name, you can see its name will be 4-bromo pent to ene. Very good. For the second one, we can see 1, 2, 3, 4. So its name will be 3-bromo 2-methyl 3-bromo 2-methyl butene. Butene. Rabia, are you able to solve this? This is 4-bromo 3-methyl pentene. Very good. Now this will be 1, 2, 3, 4. 1-bromo 2-methyl butene. Then it will be 1-bromo butene. This will be 3-bromo 2-methyl prop 1E. Is that clear, everyone? 3-bromo 2-methyl prop 1E. Rabia, are you done with this? Okay. Can we move to the next question? So very simple question I'm going to give you. And this is also from NCERT basically. Rabia, you have completed this chapter, right? Rabia, why are you not responding? Am I audible to you? If not, let me know. This reaction you need to complete, both of you. No, you missed few classes in between. Cover it up. You will get the video lecture if you will contact the admin. You see, can you tell me what type of reaction is this? Name of the reaction. You can see this is your alkene double bond, and this is your hydrogen halides, hydrogen bromide. So can I say this is your Markovnikov? So this is your negative part, this is your positive part. Negative part will go to that carbon which has lesser number of bond, and positive part to that carbon which has greater number of hydrogen. And the rest part will be similar. You can see double bond is also present inside the ring. This is your benzene, and this double bond is basically very stable due to the presence of resonance. Due to resonance, it is stable. It is called aromatic compound. That's why this HBr will not be attacking in the ring, and this is what it will form, the product. Whereas you can see HBr in the presence of peroxide is anti-Markovnikov, and anti-Markovnikov says that negative negative part will go to that carbon which has greater number of hydrogen, and positive to that carbon which has lesser number of hydrogen. Are you getting my point, both of you? Please let me know.
Yes, sir.
Okay, so the same product, basically all the other things will be similar like this. The benzene is as it is, CH2, and then CH is there. Now this double bond will be broken, form single bond. Hydrogen is here, hydrogen is here. Negative part will come to that carbon which has greater number of hydrogen, positive to that carbon which has lesser number of hydrogen. Again, you can see this is your double bond, and this is your hydrogen halides without peroxide. That means this is your Markovnikov, and I think you can do this. So whenever you are going to do any type of question, you should first recognize the type of reaction, something like that. So it will be CH3, CH2. This negative will go to this, so it will be CH and then Cl, and then this becomes CH3. Isn't it easy? Very easy. It is, right?
Yes, sir.
Okay, I'm going to give you again a question from NCERT in text, and I hope you can do this. Can I change the slide, both of you? Rabia, you're not responding today. Rabia, can I change the slide? Okay, which one you want me to repeat? Always remember this, very simple. If there is an alkene, that means double bond. And if you have hydrogen halides like this is called Markovnikov. And if you have an alkene with hydrogen halides in the presence of peroxide, this is called anti-Markovnikov. In this, what happens? This is your negative, more electronegative. This is your positive, less electronegative. This will go to that carbon along double bond, which has lesser number of carbon, lesser number of hydrogen, lesser number of hydrogen. And this positive go to that carbon along double bond, which has greater number of hydrogen, greater number of hydrogen. And anti-Markovnikov is opposite of Markovnikov. This is negative, this is positive. So negative part of anti-Markovnikov will go to that carbon, greater number of hydrogen, and positive to that carbon, which has lesser number of hydrogen. Are you getting my point? Yes or no? Rabia. Okay. If you're still not able to understand, just let me know. So you can see this is your double bond, and this is your HBr without presence of basically absence of peroxide. That means it is Markovnikov. Here it is peroxide. You can see. So it is anti-Markovnikov. Please do that. I'm waiting. Are you done with this, Aisha and Rabia? Chavez? Okay, please do it. Chavez, why did you join at this time? Your class time was at 8 p.m. IST.
You mean 5:30, sir?
8 p.m. IST.
Uh,
Yes. What time at your place right now?
okay. Sorry, sir. I forgot the timings.
What did you say?
Yes, sir. It's 6:30, sir. Sorry, 7 o'clock.
Okay.
Sir, I forgot the time.
Okay, no problem. Please contact with admin. They will tell you the timetable correctly.
Okay, sir.
Aisha and Rabia, what about you? Oh, very good, Aisha. Rabia, what about you? Are you not getting any answer? So I'm going to write the answer. You just match it.
Sir, I did.
Okay, very good, Savage. So basically, you just need to remove the Cl and add OH. So this will be chlorocyclohexane. And with this, you can see Br2 in the presence of UV light. So basically, this is your halogenation reaction, which will take place in alkane. And this is your alkane part. Either you can remove hydrogen, substitution reaction is there. You can remove one of the hydrogen from here and add Br, and either you can do this like this. Two product will be there like this. This will be as it is because it is benzene aromatic compound. Either you can do this or either you can add bromine to this part, CH2, CH2Br. So what I want to tell you is that this is your major product. So we are going to only focus on this. This is your minor product. Less stable because this is your secondary and this is your primary. So this is your major product. The next we can see is your again HCl. You are just going to replace this. You are not going to replace this because this becomes phenol and it is in conjugation. So it is in resonance. So you just need to replace this. After this, you are going to react this with HI. So what you need to do, Markovnikov reaction. What I told you, this is your alkene. Okay, and this is also alkene, but this is in conjugation, which makes it aromatic compound. So HI, that means Markovnikov, this is negative, this is positive. So this negative will directly go to this because this carbon has 0 hydrogen and this carbon has 1 hydrogen. So negative part will go to that carbon which has lesser number of hydrogen. So this will be the product. This is your name reaction. I think its name is what? Swartz or Finkelstein? Aisha and Rabia and Savez.
It's Finkelstein.
Finkelstein reaction in which we prepare especially the iodoalkane. So this will be replaced by iodine. So CH3, CH2I plus NaBr. And again, Br2 is there. You cannot break this. I told you Br2 in the presence of UV and heat, that is going to occur only with alkane, and this is your alkene. So you just need to do this. This part will be as it is, just remove hydrogen, add bromine. Rabia, is that clear? Very good. So basically, we just started this chapter, and I'm going through only the NCRT today. Have you revised SN1, SN2? Yes or no? Aisha, have you revised SN1, SN2? Sir, I have not revised. Okay, please do this.
Sir, I did, sir.
Yes, which one will have the maximum dipole moment?
Sir, first one.
First one, very good. First one, very good. So, can anyone tell me, out of this 1, 2, 3, which one will have dipole moment equals to 0? If someone will ask you, what will be the order of
Last one.
dipole? Yes. Last one is basically tetrahedral, and if all the groups are same, like CCl4, CH4, then mu will be equal to 0. I can explain in this way: Cl, 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 Cl. And you know that chlorine is more electronegative. So this chlorine will attract towards itself this chlorine. So this will both cancel each other, and this chlorine will be attracting in its direction. So this chlorine will, so mu equals to 0. In the same way, you can do the rest: chlorine, 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 and hydrogen is there. Now what will happen? This will attract its in its own direction. So this and this will be cancelled. This will attract in this direction, and this will attract in this direction. And for the first one, you can see chlorine, chlorine is there. Hydrogen, hydrogen is there. So this will attract like this will attract like this. So this will have most. Aisha got it. Okay, I'm going to give you another question. Please do it. Any answer, Aisha and Rabia? Aisha, any answer? Okay, just check it. SN2, would you expect to react more? Which alkyl halides from the following pairs would you expect to react more rapidly by an SN2 mechanism? SN2, if you're going to write the reactivity series 1 degree, 2 degree, 3 degree, this is the SN2. This is your 1 degree, this is your 2 degree. So this will be the fastest for SN2. This is for SN2. If you are going for SN1, it will be 3 degree, 2 degree, 1 degree. Because in SN1, carbocation formation takes place. And you know, carbocation 3 degree is more stable. For this is your 2 degree, this is your 3 degree. So this will be most. Now this is your 1 degree, this is also your 1 degree. But this CH3 is nearer to this, and there will be steric hindrance. Steric hindrance. So if you are going for SN2, this will be the answer. Aisha is all correct with this, all of it. Yes or no?
Yes.
Very good. This question is for SN1. Let me know the answer.
So I've sent the answer.
Very good. First one, then first one. Both are first one, right? So for SN1, this is your 3 degree and this is your 2 degree. So this will be, this is your 2 degree, this is your 1 degree. Very good. Very good. Next is your this. This question is very important and this is reaction based question. You can see this is the question. You need to tell me what is A, B, C, D. So you are going to first write the question and accordingly solve it and then let me know. Let me know if you are not able to solve this. No, very easy it is. First, what you are going to do. This will form basically, Grignard reagent. This Mg directly attacking on carbon, so it will form MgBr. Yes or no? After this, if you are going to treat this with H2O, as you can see, we have H plus and OH minus. And this will have positive, this will have negative. So this will go to this. So you will get B as cyclohexane and the byproduct will be MgOHBr. Now, this is your RBr and Mg. You cannot do directly C. First of all, go there. CH3, CH, CH3D. You are getting CH3, CH, CH3D. So what I am going to do, D is there. That means basically MgBr. So it will be something like this: CH3, CHBr, and then CH3. Now, if you are going to treat this with magnesium, what you will get? You will get CH3 and then CH, and here comes MgBr. It will be like this. Yes or no, Aisha? There is
Yes,
nothing here. Now, this is your C, right? Let's say that this is your C. Now, if you are going to treat this with D2O, just like H2O, D is deuterium. So there will be D plus and OD minus. Now, you know that this will have plus and this will have minus. So this will attack on this and you will be getting CH3, CHD, and then CH3. So exactly this is your C. Are you getting my point? Yes or no?
yes,
Okay, please do it up to this. Try for R1D, for D this D, E. Have you solved it? Yes or no?
no, sir.
Very easy it is. So this is your scenario and you are getting it from sodium ether alkyl halide. That means this reaction must be Wood's reaction. Yes or no?
Yes,
In Wood's reaction, what happens? Whatever you take, it becomes double. So what I'm going to do, just break this into parts. So it will be CH3 and then CH3 and then CH3. There is a C as well. There is a C like this, and there is this carbon. Between this carbon is with chlorine or anything you can take X. You can take X. And if you are going to react this with 2 times of sodium in the presence of dry ether, what will happen? This will be doubled itself, yes or no? This is what happens in, what do we say? In Wood's reaction, yes or no? So if it is going to be double, so what will be the product? CH3, C, CH3, CH3. Now you are going to double it, so C, CH3. Mirror image of this basically. So what I want to tell you is that this and this are same. So this is your R1. Basically, this part is your R1. Are you getting my point?
yes, sir.
Now, if you are going to treat this with magnesium, if you are going to treat this with magnesium, you know what will happen, right? Yes or no? Again, this will form, just wait a minute, let me see, Mg and then H2O. Now what will happen? Very simple. This magnesium will directly go to carbon, so it will become CH3, CH3, and there is CH3, and this becomes MgX. And after this H2O, that means H plus and OH minus again. So this will be directly going with carbon, so it becomes CH3, CCH3, CH3, and there is H. So this is your E, and this is your D, and this is your R1. Got it? R dash or R?
Yes, sir.
Please do write it. Let me know.
Done, sir.
Are you done with this?